Good morning to everyone. So first here, I am going to start the unit 1 in communication system. The unit 1 is analog communication. In analog communication, we are going to study about amplitude modulation, frequency modulation, and phase modulation. So before we are starting this, the topic, before that we know what is communication system, what is the need of communication system. Okay. So what is communication system means here the communication is a process of establishing the connection between the 2 points or the sender and receiver for the information exchange. That is communication. Okay. So here in communication, we are going to study some important concepts of communications. So communication, it is a process between the sender and receiver exchanging the information. But here we building a connection or link between one point to another point for exchanging information. So these are the concepts behind the communication. So here different communication equipment including transmitter, receiver and communication channel that assembled for a communication system. So communication means the information exchange between the sender and receiver or one point to another point. Okay. But communication system means here it including the transmitter, receiver and communication channel. So that assembled to get a communication system. Okay. So here it ensures the data such as voice, video, text or something. So it is delivered efficiently and accurately and securely. So this information being transmitted can be in either analog or digital form depending upon the type of communication we can use. Okay. So we know the basic communication system have transmitter, receiver and the channel, the transmission medium. So the transmission medium becomes the wireless or wired channel. So the above these three things are present in any communication system. So whenever the two people are talking with each other, so it becomes a communication system. So in that case, the voice signal is exchanged and the transmission medium through the transmission medium. So okay. So then what is the need of communication system? So we are going to study about what is the need for communications, why we need communication system. So here we can transmit the information over short range communication or long distance. So to enable the fast and reliable communication and to support the real-time communications, the calls, video conferencing or anything. So to connect the devices and networks through internet and mobile systems and to improve the efficiency and reduce the manual effect. So, and support the modern technologies like satellite and wireless communication. So the main thing is here, the transmission, why we need for transmission means that transmit the information over that is short distance communication or long distance communication. So, and we need the fast and reliable communication. Then real-time communication is including calls, video conferencing and audio. So it will connect all the devices and networks through internet and mobile phones. So these are the needs for the communication system. Okay. Then we show this block diagram, the basic communication system block diagram. So here the input is the source, information source, and then the transmitter, then after that the channel and the receiver. Okay. So the basic communication system includes the transmitter, information source and sender or transmitter, and there is a channel and receiver. So here the transmitter means the first the information source, that is the information is analog or digital information. After that the receiver, transmitter. So it sends the information. For example, TV transmitting station or audio transmitting stations are senders. Okay. So since they transmit the information, so once transmit the information, it includes source encoder, channel encoder and modulator. Okay, these includes, these are the transmitter. Okay, then the receiver, the receiving side, it receives the information. For example, in TV sets or radio or receivers. For example, TV and radios are receivers. They get information from the transmitter. Okay. Then after that, in between the transmitter and receiver, there is a channel. So this is the transmission medium between the transmitter and receiver. So here, this is the path through which the signal propagates from the transmitter to receiver. Okay. So this, the example of transmission channel means here in wireless communication means here is a transmission medium. Then in wired communication, the channel is the cable wires, the optical fiber optic cables or coaxial cables. So here we are going to study about the elements behind the transmitter and receiver. Okay. So first of all, the basic structure of communication system, how the information is transmitted from source or from the sender to receiver or from source to destination through the components like transmitter, channel and receiver. So while noise may affect the signal during the transmission. So the first one is here the information source. So what is the information source? So here it generates the messages and voice signals and text or video. So then the information source and input transmission means the source of information can be, it is analog or digital. For example, analog or video signal or digital means here the teletype signals, then zero binary numbers, zeros and ones. So the digital communication, the signal produced by the signal is converted into digital signal, which consists of the binary numbers, zeros and ones. So for this, we need a source encoder. Okay. So then after that, it is applied to the source encoder. The information is sent to the source encoder. So here in digital communications, we convert the signal from source into digital signal. Then the source encoding or data compression. So here it is a process of efficiently converting the output, whether the analog or digital source, into a sequence of binary digits. So it is known as source encoding. Okay. Then the channel encoder. Channel encoder means here the information sequence is passed through the channel encoder. The purpose of the channel encoder is to introduce, it is controlled manner, some redundancy means that repeated information, the redundant information in the binary information sequence that can be used at the receiver to overcome the effect of noise and inference encountered in the transmission on the signal through the transmission medium or the channel, transmission channel. So here the changes the messages into a signal that can be sent through the communication channel. So that is called, it is a modulation. So here, then after that, the transmission medium. What is the transmission medium? Here, the communication channel is the physical medium that is used for the transmitting signals from transmitter to receiver. So the medium, it is, I already told, it's a wireless medium or wired medium. Suppose wired medium means it is a coaxial cable or optical fiber. In wireless means it is the air is the transmission medium. So in wireless system, the channel exists of atmosphere for traditional telephony. So this channel is wired, that are optical channels or underwater acoustic channel, etc. So we further discriminate the channels on the basis of property and the characteristics like AWGN means here additive white Gaussian noise channel. So the noise means here the unwanted information or unwanted signals that affect the signal during the transmission. So the unwanted disturbance or unwanted noise, this will affect the original information. Then after that, the receiver. So in the receiver operation, it recovers the original information from the received signal because the received signal contains noise and our original signal. So we need to recover the original signal from the received signal through the demodulation process. So this is the process behind the receiver. Then after that, the destination, the final user or device that receives the message. Then in the receiver side, what are the components inside the receiver? Here, so a channel in the transmitter side, channel encoder and source encoder. So here channel decoder and source decoder. So what is the function behind the channel decoder means? This is the sequence of numbers then pass through the channel decoder, which attempts to reconstruct or recreate the original information sequence from the knowledge of code, the random code used by the channel encoder. So then the redundancy contained in the received data. In the source decoder means here the analog signal is desired, then source decoder tries to decode the sequence from the knowledge of the encoding algorithm. So which results the approximate replica of the input at the transmitter end. So we can receive the original or recover the original information signal sent by the sender. Then so here analog and digital, analog to digital conversions. Okay, so it is a representation of analog information by analog signal. One may ask why we need to modulate an analog signal. So it is already analog. Modulation is needed for medium is band pass in nature, or if only a band pass signal is available to us. So here we are going to then discuss the topic amplitude modulation, frequency modulation, and phase modulation. So here, what are the different types of modulation under analog to analog conversion? So here, first one amplitude modulation, then frequency modulation and phase modulation. So what is amplitude modulation? So here, the amplitude modulation means here the amplitude of the carrier wave is varied in accordance with the modulating signal. Okay, so the carrier remains the same, but the amplitude of carrier wave is varied in accordance with the modulating signal. Okay, so the modulating signal is the envelope of the carrier. So the required bandwidth is 2B. So here B means the bandwidth of the modulating signal. Or we can set that required bandwidth B equal to 2FM. That means twice the frequency bandwidth of the modulating signal. Okay. Then here both side of the carrier frequency, then FC, the spectrum is identical. We can discard one top that requiring a smaller bandwidth of the transmitter. So this is the waveform of amplitude modulation. So here the first waveform represents the modulating signal. So this is the low frequency signal, sine wave signal. Okay. Then here the second one is the carrier frequency. The carrier frequency means here it is the high frequency signal carrier wave. Okay. Then the third one is the modulated signal. So it includes the modulating signal. That means the information signal plus carrier signal. Okay. So this is the system for amplitude modulation. Here the modulating signal is applied to the multiplier. In the another side, the oscillator produces the carrier frequency. Both are multiplied by the multiplier. Then the output is the modulated signal. So we can represent the waveforms. Let us the modulating signals to be the M of T. The M of T represents modulating signal and C of T represents the carrier signal. So the M of T here it is equal to AM cos 2 pi FMT. So here AM means the amplitude of the modulating signal. Then the carrier signal can be represented by C of T equal to AC cos 2 pi FC. So here AC represents the carrier signal. Then the modulation of the amplitude of the carrier signal. So here FM and FC are the frequency of the modulating signal and carrier signal. So this represents FM represents the frequency of modulating signal and FC represents the frequency of the carrier signal. So what is the modulated waveform means here S of T. The S of T represents the modulated amplitude modulated waveform. So it is equal to AC plus AM cos 2 pi FMT into cos 2 pi FCT. So this is the first equation. So the carrier wave after being modulated, if the modulation level is calculated, then such an attempt is called the modulation index. So or modulation depth. So it states that the level of modulation that the carrier wave undergoes the that means the ratio of amplitude modulation of the amplitude of the modulating wave and the amplitude of the carrier wave. That means AM divided by AC. Okay. Then here the modulated signal means S of t, it is equal to we rearrange the first equations, that is AC equal to 1 plus AM divided by AC into cos 2 pi FMT and cos 2 pi FCT. Then the modulated signal S of t, again we rearrange this equation. It is equal to AC into 1 plus mu cos 2 pi FMT cos 2 pi FCT. Here, the mu represents the modulation index. So, modulation index means the ratio of the amplitude of the modulating signal to the carrier amplitude of the carrier signal. So, here we can replace the AM divided by AC into mu. So, mu equal to AM divided by AC. So, we can write the S of t, it is equal to AC into 1 plus mu cos 2 pi FMT cos 2 pi FCT. So, here FM represents frequency of the modulation signal and FC represents the frequency of the carrier signal. T represents the time. Okay. So mathematically, we can write the modulation index mu, it is equal to AM divided by AC. So again, we are going to how to calculate the modulation index. So here, let the A max, it is the maximum amplitude of modulating signal, that is A max, and A minimum be the minimum amplitude of the modulated signal. So here we will get the maximum amplitude of the modulated wave, then cos 2 FMT is equal to 1. So then A max it is equal to AC plus AM. So it is equal to A max, it is equal to AC plus AM. So we will get the minimum amplitude of modulated wave. Then cos 2 pi FMT is it is equal to minus 1. The only thing is the maximum amplitude of the modulating wave is when cos 2 pi FMT is it is equal to 1. Then the A max is AC plus AM. Then the minimum amplitude of the modulated wave means we will get then when cos 2 pi FMT it is equal to minus 1. Okay, then A minimum it is equal to AC minus AM. So A max plus AM, so A max plus A minimum it is equal to AC plus AM plus AC minus AM. So we can add both the equation. Then AC plus AM plus AC minus AM. So it is equal to 2AC. So AC equal to A max plus A minimum divided by 2. So we can get the finally AC it is equal to A max plus A minimum divided by 2. Then after that, the A max minus A minimum it is equal to AC plus AM minus AC minus AM. So it is equal to 2 AM. So we can get AM it is equal to A max minus E minimum divided by 2. So solve this equation. So we can get AM it is equal to A max minus A minimum divided by 2. So finally we got AM divided by AC. So we can divide this equation AC and AM. So AM divided by AC it is equal to A max minus A minimum divided by 2 whole divided by A max plus A minimum divided by 2. So mu equal to A max minus A minimum divided by A max plus A minimum. So this is the equation for calculating the modulation index. So the modulation index or modulation depth is often denoted in percentage, called as the percentage of modulation. So we will get the percentage of modulation just by multiplying the modulation index value with 100. So this is the modulation index of the amplitude modulation.